All right, guys, let's continue. So today we're beginning binomial expansion, and through that, we're going to look into the binomial theorem and everything. So first, we need to understand what does the topic essentially mean. And if we are trying to understand what does binomial expansion mean, we need to know exactly what are we talking about. So if I say that um, there is a series, for example, there's a sequence or there's some sort of series, and that is going to be produced. Now, whenever we say that a series is being produced or there's a sequence that is running, the sequence, if you guys look at it, it's increasing, right? Usually the sequences increase, or even if they're decreasing, it's kind of like the sequence is expanding. Before there were like one term or two terms, and now it's like kind of like expanding. That is more or less going to be the case over here. The major difference between series and binomial expansion is that, first of all, what are these? That is what we're going to see. So, can anyone tell me what is the meaning of the word binomial?
So it's kind of in the name. Like bi is like two, and nomial is like names.
Yeah,
So that's
you're
like
up.
two basically.
You're absolutely right, Barsa. So, for example, I can even break this guy down. So, Barsa is absolutely right. This is in the name. Technically, what it means is that if we try to break this down even further, what does bi and nomial means? This means two, this means numbers, or in our case, this time around, we are going to refer to it as terms. Clear? Secondly, what is expansion? Now, what is expansion in this case scenario? That is what we're going to discuss too. It is simply the expansion of what you may call expressions. And we have done those before, like, in back in IGCSEs, and when they're trying to teach you algebra and factorization, and they tell you expansion of brackets, this is what's up. So expansion of what you may call expressions is going to happen over here. Similar to, so what is essentially happening over here, if we group all of this together, if we group all of this together, it is kind of like a two term a plus b or minus b, whatever it is being expanded. Now let's look into the actual definition of what is binomial expansion. So if I were to describe to someone how or what am I talking about in terms of binomial expansion, it is simply going to be the it's referred to as a type of series, a type of series produced during the expansion of a two-term expression, of a, a two-term, or a binomial expression. So in very simple words, it's the expansion, or it's a type of series or a sequence produced when you expand a two-term expression by a given power, by a given power. Clear? So it's a type of series produced during the expansion of a two-term expression by a given power. What do we mean by that? It is going to be what you may call, for example, if I were to quote an example here, if I say that a plus b is being whole squared, and so that expands to what? Now, this is a two-term expression which is being expanded by a certain power, and what does it yield? So this two-term expression yields a square plus 2ab plus b squared. So from this two-term expression, which was being expanded by a certain power, I received multiple terms. So it became a polynomial expression. From a binomial expression to a polynomial expression. Is this clear? And what do I mean by what you may call polynomial? Yes, can someone tell me what is polynomial?
Many names.
What, sorry, person?
And it's the same thing with binomial. It's kind of in the name. That's many names.
Yeah. So it's kind of like if we were to, uh multiple powers of variables in an expression. All right. So in an expression. So it's multiple powers of variables in a particular expression. What is going to happen now is that it is simply going to be continuing forward, like just as I gave you guys an example of this. What is that going to do? For example, the usual example that I gave is x plus 1 raised to the power 1. That is going to give me x plus 1. But similarly, if I oh, if I keep on copying this down further, and I keep on flipping the powers, like I keep on changing them. So it's going to be 2, 3, 4. Obviously, it's going to change. So it's going to become x squared plus 2x plus 1. So now you have a polynomial expression. Then it's going to become x cubed plus 3x squared plus 3x, if I'm not wrong, plus 1. And then it's going to become x raised to the power 4 plus 4x cubed plus 6x squared plus 4x plus 1. And it is going to go on till it can. It can continue along its merry way. Same goes for the expression as well. All right, you can keep on changing the power. It is going to keep on expanding. Now, there will come a time at one point that, now let's look into the general form of this. So the general form of this expression, this particular one could be x plus 1 raised to the power n. Now, how do you solve this sort of expression, or how do you know how many terms you're going to get? That is going to be determined by simply, or how do you know at what position which term you're going to get, or how many terms you're going to get? that is all going to be determined by something called the binomial theorem. Binomial theorem, which is very simply just this, that if I write down the general form of the binomial theorem, it is going to be, let me reduce this arrow. Oh wow, it doesn't reduce. In order to know how or what, because there will come a time when the expansion will become out of control. For example, up to this point, it is still manageable where the powers are equal to 4. But like, let's say, what if the power is like 27? What will you do then? Will you write the number of countless number of terms there, or what will you do? So in order to get rid of this, we came up with the binomial theorem, which states that for a binomial expression being expanded by a power of n, that is going to be equal to NCR a times a raised to the power n minus r times b raised to the power r. Parsa, no for anything that you guys don't get from this. It's very easy, guys.
Clear.
No, sir, it's clear.
It's a very simple formula. Now let's see what do I mean by the r and stuff and all of that. Your first of all, n is the power on top of the binomial expression. So it is the power of the binomial expression. Your what you may call R is the required power that you want to find. Like for example, at what point are you trying to, or what power of x are you trying to look for? Because obviously, if it's a binomial expression in terms of a variable, then obviously what is going to happen? It is going to be a binomial expression in terms of a variable. So it is going to be expressed in polynomial as a polynomial expression. And what is a polynomial expression? It contains multiple powers of that particular variable. So in a question, if you're asked to find a particular answer, like if you're asked to find the variable when it's the power is equal to like four, or when the power is equal, or what is the coefficient of that variable when the power is equal to 7, or what is the term going to be equal to when the power is equal to 3 or something like that, and your total expression is being expanded to a greater power, you can use this formula because R is going to be the required power in the question. All right, required power of the variable. Is this clear, guys? Pasha, Nopal, anything that you guys don't get from this?
No,
No,
sir.
sir,
Clear.
Now, usually students ask me, and this has been asked, that how do you get the C? C is it's known as combination, but currently you guys are not like it's not required for you to know how it works or what it is. I'll let you know. But some students ask me how to make it appear on the calculator. It is different for most calculators, but from what I have always seen is that on your calculator, if you have a shift box, I think everyone does. That's kind of like the main thing. So if you have shift on your calculator and you press that in, and first you press shift, then you press your division sign, and on top of the division sign, at least this is what it does for my calculator. So that is going to give you, when you press the division sign, that is going to get you C. Clear? And usually in some calculators, it's also written on top of C, NC, on top of the division sign NCR. Clear? So that is how on your calculator you can, get to this C. Clear? If there's an issue operating your calculator, guys, do let me know. Also, this is how you operate it on your calculator. All right. Now what's going to happen is, very simply, let's see what is actually happening, because usually students are, they are completely, not sure as to what is happening. So I'm going to explain this guy. Like what is happening over here. All right, let's see what is happening over here. So for example, wait, I should use a lighter shade. I can't even see myself. So when I say NCR, what do I mean? Let's see. When we say NCR, what do we mean by this is that technically it means n factorial over r factorial times n minus r whole factorial. Now, what is factorial? And let's see now. Whenever we're trying to see what is factorial, first of all, it's this symbol, like an exclamation mark. Clear? Secondly, what you're going to have is that what is factorial? Now, let's see. If I were to, I can only explain factorial through an example. Like, I don't know how to describe it, like in terms of words. So if it's written 5 factorial, what does that mean is that means you multiply 5 with all the numbers that are preceding it. Like all the numbers that come before 5, you multiply it with it. It's going to be 5 times 4 times 3 times 2 times 1. Usually some people skip out 1 because regardless of whether you multiply it with 1 or not, it is still going to be the same answer, but you are supposed to multiply it by 1 in terms of, theory. In theory, we do multiply with 1 as well. So this is what's happening. Any sort of factorial is all the numbers preceding it. Clear, guys? I hope that's not an issue. This is
Yeah.
clear.
Yeah.
Okay. Now, some students have also asked me how to get the factorial bit on them. Like how to, just fix it over here. Like usually a lot of people struggle with their factorial bits. So what is going to happen is that now it's different for a lot of students too, in terms of, actually it's different for calculators as well. But usually what happens is that, you press this button. There's supposed to be an X, and there's supposed to be an X inverse sign, I think, if I remember correctly. And on top of that, it's supposed to be an X like this, written with golden. And by the way, I use a Casio calculator, so that is why I'm getting this. So you're going to get a factorial. I hope it works this way on your calculators as well. Does it?
Yes, it does.
All right, Nofal, what about you? You know how to use it?
Yes, sir. I know. It works.
All right. Yeah, because I'm only asking because it's different for every calculator. So, and there are YouTube videos as well on how to operate your calculators too, because there are a lot of models. Now, going back to our formula. So if I expand my formula, which is NCR, this is what my calculator is doing in the background. It is taking factorial of n over the combined factorial of r factorial times n minus r whole factorial. And what was factorial? All the numbers preceding it are multiplied with the original number. Is this clear? So, for example, if we were to explain this with the help of an example, we can simply say that if I say what you may call 5C3. Technically, what is happening now, you can simply type it on your calculator 5C3, but technically, what is happening is n is your 5 factorial over 3 factorial times 5 minus 3 factorial, which is technically 2 factorial. So 5 factorial is all the numbers preceding it. So what is going to be the value of 5 factorial? You guys should know. And over 5 factorial over 3 factorial and times 2 factorial. So yes, guys, can you solve this and let me know what's the answer for this? Come on, people, I can do this. If it takes too long, I can do it mentally. 20, 60, 120. This is 120.
It's 10.
Yeah, it's 10. All right.
But then I realized I was muted.
Okay, okay. It's 10. Is this clear, everyone?
Yes.
Is there anyone who still doesn't realize what just happened?
No, sir. Clear.
All right. That is perfect. Wait, let me add some beauty to the formula. Looks nice with the ribbon thingy. Nope, too big. Right about here. Okay, that's okay. All right. So that has what has happened so far. We now know that your binomial theorem is used to simply find out how to expand and how to expand a binomial expression with a given power. Is this clear? Now I would have begun the binomial theorem further, but I don't want to be left with the what you may call. Okay, one thing I can tell you is that continuing with this over here, the total number of terms in an expression, the total number of total terms in, or you can say after an expansion are always equal to n plus 1. All right. So the total number of terms after every expansion are equal to n plus 1. How so? You can test this theory too. When the power was 2, when the power was 1, there were 2 terms in the expansion. When the power was 2, 3 terms. When the power was 3, 4 terms, 5 terms. So if you want to know the total number of terms in in a binomial expressions expansion, it is just the power on top of the expression, and you add 1 to it. Clear, guys? Is there anyone who still doesn't get it? Yes, people. Done with it?
Clear.
Yes.
All right, well done. So we're going to leave it till here for today, guys. I wanted to start off something, but then I'll be what you may call, I won't be able to finish it in time. So we'll just continue, leave it till here for today. We'll continue this tomorrow. Okay. Apologies for arriving late today. And tomorrow we'll be done by it. I just have to tell you the 3-4 types of expansions there are. Then I'll just give you the question that we were supposed to do in class. I'll just give you them as homework. Clear? All right.
Yes.
As always, keep smiling, guys. And also, I'll post the notes as well on Google Classroom and the recordings. Yes, I remember. Bye bye, guys. Allah Hafiz.
Bye.
And